Welcome! So we're going to talk about chemical bonds, me and the Elmo here, right now projecting periodic table of elements. So chemical bonds, real quick, three main types. We got ionic, covalent, and metallic. This video we're really going to concentrate on ionic and covalent, go through some Lewis dot, and show you how all this is arranged. So, ionic bonds. When we look at ionic bonds, we're really looking at the transfer of electrons. So here's a description of ionic versus covalent. We should know that ionic involves metals, nonmetals, and covalent is between nonmetals. We'll go to the periodic table to show that. Ionic bonds, again, transfer of electrons. Covalent, we share it. CO means together, so covalent means they're sharing them together. Think of cooperate, operate together. Here's our periodic table real quick. We got our columns here, our groups, and we got our rows or periods. If you remember, with just the main blocks, so if we don't include these transition metals between 3 and 12, the main block, our column, which is our group, tells us the number of valence electrons, and our row, which is our period, tells us the number of shells. All right. So, for example, let's look at sodium chloride. With sodium chloride, it's a main example of a ionic bond. So here we go with our sodium and chlorine atoms. Going back to our periodic table here, sodium, where are you at? Oh, here you are in our first column. So we know it's got one valence electron because it's in our first column. And then we go over here to chlorine, which is in, again, we're skipping the transition metals. We got 1, 2, 3, 4, 5, 6, 7 chlorines in our seventh column, which tells us the number of valence electrons is 7. So here's what the shells would look like. You got sodium here with its 11 electrons, 2 in the first shell, 8 in the second, 1 left over, and then chlorine is 17 electrons. We know this from the atomic number. And so 2, 8, and then 7 in its outer shell, which is its valence shell. Now you may say to yourself, oh, I remember atoms, they want to be stable. What's stable look like? Stable means it has a full 8 electrons in its outer shell. Well, chlorine's got 7, sodium's got 1. What's going to happen? So this is an ionic bond because we have a metal, sodium plus chlorine, a nonmetal. We want to get to 8. 8 is going to give it stability, and the 8, again, in the valence electron, the outer shell. Well, what if sodium loses its electron, and so it's transferring an electron to chlorine? That means chlorine's going to pick up its 8th electron. Now it's got a full outer or valence shell. Well, what about sodium? Well, it lost this one, so it no longer has this shell at all. And we're left with 8 electrons in this shell, which now is its outer shell. So what's that going to look like from a Lewis dot perspective? Well, again, sodium's got 1 valence electron. Chlorine's got 7. So we notice that we can transfer 1 electron. Well, if you lose an electron, that means sodium becomes, if it lost a negative, it's going to have a positive charge. Chlorine gained an electron from sodium, so it's going to have a negative charge. These are called ions because an atom that's either gained or lost an electron becomes an ion. Well, this one's positive, this one's negative. This is going to keep them together. All right. So here's sodium and chlorine. Again, they have opposite charges, which is going to attract them, which is great. So that's sodium and chlorine, and we can write it as a chemical formula of NaCl. What this means is we got 1 atom of sodium and 1 atom of chlorine. Let's look at another example. Let's go ahead and look at magnesium iodide. Magnesium iodide, again, we got a metal and a nonmetal. So let's find magnesium. Magnesium's here in the second column, which means it has 2 valence electrons. We know it's a metal because it's here on the left-hand side. And then we got our nonmetals on the right-hand side. And when we look at, we got iodine, which is in the same group as chlorine, so it's got 7 valence electrons. Here's what it's going to look like from a shell perspective, electron shell perspective, is we got magnesium with its 12 electrons, and we got iodine with 53 electrons, 2 in the inner shell, 8, and then we got 2 left over for 12 total. And then iodine is, it's a little bit different. We're not going to go into the suborbital shells, so we're just going to look at the outer shell, the valence electron, and we know it's in the 7th column, so it's got 7 valence electrons. So let's go and look at it from a Lewis dot perspective. Well, we got 2 valence electrons for magnesium, so 2 valence electrons. I'm going to put it over here just to make it a little easier. And then iodine's got 7. Well, iodine only needs 1, and magnesium wants to give up 2, so we're kind of here a little impasse. Well, what's going to happen? All right, nerds, you probably figured this out. We're going to have magnesium is going to lose its 2 electrons. Well, how can it gain a full outer shell? Well, what if magnesium bonds with 2 atoms of iodine? So we got a transfer of 1 electron here to iodine and another one here. That leaves magnesium with a full shell of 8, and then each of the iodine atoms gets a full shell. So now we have 1 atom of magnesium, 2 of iodine. We got some happy campers here, and here's our sort of chemical formula for that. And we're left with, since magnesium lost 2 electrons, it's got a positive 2 charge, and each of the iodine atoms gained 1 electron, so they're going to have a negative charge. So here we go. Magnesium iodide, we have, again, iodine has 2 atoms. Magnesium lost its 2 electrons, and each of the iodine atoms gained an electron. All happy campers with that full valence shell. What if we look at covalent bonds? So let's look at some covalent bonds. Well, how about hydrogen and hydrogen? So again, we can draw out the shells here, and we realize hydrogen, number 1 on our periodic table with 1 proton and 1 electron. Here we go. Well, it wants a full outer shell for hydrogen. That's 2 electrons in its outer shell. So what are they going to do? Well, they can't lose or transfer any electrons, but what if they share them? So what if instead they share these, and we're left with each of them having 2. So now we have our Lewis dot, each one has 1. We share these. We can represent that with a covalent bond. We can represent that with a line. So what this line means is it's a bond. So this is 1 bond, which is sharing 2 electrons. I write E negative for electrons. They're both happy because they have a full valence shell. And then let's look at one of the most important molecules here on Earth, H2O. Again, we got hydrogen here with its 1 electron. Oxygen is in the 6th column, so it's got 6 valence electrons. Well, this kind of works out well because we have oxygen with its 6. We have hydrogen with its 1. Hydrogen with its 1. Well, what if we share them? And now oxygen is left with 8, hydrogen's got a full 2, and we got our friend H2O. Well, how does that look like with bonds? Well, we got oxygen, it's sharing electrons with hydrogen. So again, this means 2 electrons being shared total, each sharing 1. And then here, oxygen again sharing with another hydrogen atom. So that's an overview of ionic and covalent. Hopefully it made sense. Thanks, Elmo. Have a good one.